Welcome, guys. Привет, Sebastian. Как дела?
Hello there. Всем привет.
Nice.
Hi. Yeah, nice Russian accent.
So,
So yes, I'm very happy to be here, to be back, at least in a virtual way. So I would love to be there in person as well, but we can do this for sharing knowledge as well. And yeah, very
cool.
excited.
So, everyone knows that the special things about your talk are the fact that you just use live coding and live demos a lot. Is this going to be the same this time as well?
Yes, you suspect that correctly. Just because, I think that's very just fun and entertaining to watch somebody to code and to do some real live demos rather than just having slides. So I try to make it a little bit interesting in this way. And of course, a lot can go fail. So if anything goes wrong and, Kubernetes explodes, then this is just part of it. It's part of the show.
Yeah, I guess so. It does happen from time to time. So, I guess, should we start with it then? Bring it on.
Let's go.
Let's go.
Тогда всем привет. Меня зовут Себастьян. Я работаю в качестве евангелиста программного обеспечения для IBM. И я учу русский, но я еще плохо говорю, поэтому I will talk in English. And I'm happy to talk about this topic with real-world continuous delivery with Tekton and ArgoCD. So we're going to talk a little bit about how to, do this in a cloud-native world. So about myself, I was already nicely introduced. I usually do things on a Java side, but also everything that is important for enterprise projects. And continuous delivery is a very important topic for that, of course. So not just if you're, a developer, or if you, as I call it, an engineer working in the project for IT projects, that's very interesting to have. And for a cloud native world, because most of the companies have moved to a cloud native environment, or at least are beginning to do so based on containers, based by Kubernetes usually, how to do some real world continuous delivery. Because a continuous delivery stack is usually one of the latest things or last things that get updated. And this is very interesting to have just something that is mature and flexible enough. Because from experience, we need quite some flexibility to cover what you have in your projects. So typically, there was always something like a big monolithic Jenkins installation that does a bunch of things. But since a lot of environments have changed a lot with this cloud native workloads based on containers, we just have to have a look what to use. And what I will show is a combination of Tekton and ArgoCD. And of course, we will do this with live demos and so on and so forth. But first of all, let's start off with one that is called Tekton. So Tekton is a cloud native based built and pipeline built technology for cloud native CI/CD. So there is a foundation now for CI/CD systems based on Kubernetes, and that is what we will use. So this is what I will show first. So it is very much based on this containerized environments. So if we use Tekton with Kubernetes, then we will have something like build steps that run as containers. So you will see that there is, there are a lot of containers involved there. And probably also if you know about, so there's this jokes about Linux. So maybe you know this picture about the Linux system. Happy birthday, here is your cake. You just have to build and compile it yourself. And now if you look at Tekton the first time, then it will look a little bit similar. So happy Tekton, here is your pipeline. Go ahead and build it yourself. And just make sure you bring a lot of containers and some Docker and a lot of YAML, right? We'll need a lot of YAML to build our pipelines. You can have Kubernetes and some cloud involved, and then we will have a built pipeline. So this is basically what we are going to use at first, and then how this comes into play in our architecture. This is just what I want to show you in this diagram here, is to, how to make this a part of our cluster is that we have some Git applications, some Git repository there where our application resides. And then we have also a config repository. So this approach, what I will show you, is based on GitOps. So we store the configuration for the environment in the on the version control as well. And then, well, what Argo basically does, it's called declarative CI/CD. So it does nothing else than just listening to some state, for example, in a repository, and applying that state. So what we do with this approach with Tekton and Argo is to have a very flexible, loosely coupled technology, a loosely coupled system, and not one big CI/CD server that does everything, but rather what we do, we have a pipeline that builds some stuff, and we have this Argo technology that just takes the definition, the infrastructure as code definition from our repository and push it against the cluster. So it will just there appear on the cluster. And what it will do, so for example, the pipeline is part of it. So the pipeline in the cluster there is also built by Argo, and then it just appears because the definition resides in the config repository. And when we build our application that will be triggered from our Git, then we will just make sure that all of these steps are performed. And ultimately, the steps, we'll see this then how this works, will also write into the Git config repository that then update just the definitions that are part of our app. So then we have a staging environment and a production environment that then get rolled out on the same cluster. Argo could also point to a different cluster. So if we have one cluster where our Tekton and Argo technology runs, it could also deploy to a different one. But that's basically what we would like to have. So for this, what I will show you is just some basic application. And maybe you also know about me, ja lubię coffee. So I have actually a coffee shop example for you. And what's quite important for me is to show you an example that's not just Hello World, because Hello World is easy. But for build pipelines, it's always interesting to have something that includes a proper test environment and multiple environments that then automatically get deployed. Because otherwise, a Hello World build, everybody can do that. But then we will see, is this really fit for a real world use case? Is this really fit for production-like scenario? And this is what we used in projects already, and this is what I want to show you. So just some more ASCII out diagrams, and then we'll show you some code. The pipeline steps that we have are the ones down there. So we build our application that is here based on Java. So we have a Java application. Why? Because I'm a Java developer, but it doesn't matter at all what technology you use. It's just about the pipeline here. But first of all, we have a Git app repository. And then we should build our app here. And well, first of all, if we build the app, it could be anything for us. It can be a Maven build. So then we have a Java artifact. And then it also includes the Docker image build. So then we produce a Docker image that we then, in the next step, deploy somewhere. ST means system test. So we deploy something to a system test environment. And how this works is that, actually, there's a typo that should, of course, if you paid attention, be git config, not git app. So it makes some changes in the git config repository. And then by doing so, you saw this, the test environment will then just appear, because here this will be then provided by Argo. And then the next step, run system test, just tests against this environment that just has been created, or that just has been updated, where our application was deployed to in the previous step. And then in the next step, we deploy to production environment. Test environment stays the same. And then we run our smoke test. So a smoke test is basically, it doesn't really execute anything. It just checks, like health check, is everything there and available, and so on and so forth. And then we verify whether our production system works. So that's the idea. And let's see how to do this. So what I have for you is a Maven project, which is called Coffee Shop. So actually we have a system with 3 containers or 3 microservices if you want, or actually 2 microservices in one database. So we have a coffee shop application and a barista application, and we will see how they work together. And this is just going to be built with Java. Okay. But now if you check out this diagram, you will see, you can have a look at this one or actually this one. You will see that we have 2 repositories, one where our application resides. This is what I just showed you. I have some Java code there. But the other one, for now, that's more interesting, our config for our GitOps repository, which is where a lot of YAML resides. So we have some resources that then will be applied on the cluster, and this is how this works. So let's have some one more look at our cluster actually. So Argo and Tekton run on our Kubernetes cluster. Where do we get a Kubernetes cluster from? Well, let's see. We could have many ways. We could install a Minikube, for example, on our own laptop. We could use a cloud environment, which is what I'm doing. So I have the IBM Cloud Managed Kubernetes Service. So I have a cluster there where I have Kubernetes and also an Istio installation. And on this cluster, for my case, everything runs. So the Tekton pipelines run on this cluster, the system test environment, and the production environment. I could also split this up to have multiple clusters. How I separate it is by using namespaces. So I have access to this cluster here in my command line using, of course, this kube control command. And I can say, just give me the namespaces here. And then we see we have, well, all kinds of namespaces there for Argo, for my production and system test environment, and Tekton pipelines. So this is basically what I have. And now what Argo does, and I can have a look at, there is a nice dashboard. And probably have to reload this. Okay, wait a second, maybe sometimes. I have a port forward, so I usually should have a proper gateway, but I'm lazy, so I only have a port forward to this Argo dashboard because I only want to show it for you as testing purposes. What it does, it syncs some specific Argo projects. So it syncs a pipeline, which is the Tekton pipeline. It syncs production and system test. So how this works is what I showed you in the diagram, that Argo just goes to the git config directory and just applies the state that will be pushed to this repository. So git config repository, I have some YAML there, and they will be applied. That's all Argo does. That's it. The rest will be done from another perspective. And then if this is the case, then Argo will make sure that all of our resources, I can check this out. So there are some Tekton resources here, for example, are applied to this namespace. I can check out the pipeline, I can check out production. Production has some coffee shop, barista, some database. It has services, it has deployments. So these are all Kubernetes resources. The good news is if that is a Kubernetes resource, we should see it on our cluster. So I can say, for example, kube control, give me the deployments of my system test namespace, and it will show me these deployments, or of course the running pods. So I can say kube control get pods of system test, and it will show me the pods of the system test or the production environment to see that all of that is in the cluster. Okay, so that's so far about Argo, but what I actually want to show you now mostly is the pipelines by Tekton. Why? Because Argo is just the declarative CI/CD. I provide some desired state in YAML. I say, please take these Kubernetes deployments, services, and apply them. That's all. If I make some changes to the environment, then we will get the changes there. But what actually I want to do is I want to have this pipeline here that my Tekton, this is now a Tekton resource, that my Tekton pipeline builds actually my application. And how this works is by having a look at Tekton. So Tekton is also an installation. Let me remove these here. That are deployed to my cluster. And the Tekton typically starts with a pipeline. So this is a resource that describes the whole pipeline. And then the pipeline typically consists of some tasks that I have here. So I have here, well, these are some four tasks for the deployment and system test steps. And now I want to walk you through how this looks in a pipeline here. So brace yourself, we're going to see a lot of YAML. Yay! I hope you all like YAML code. What we have is our pipeline definitions. These are, as you probably saw, these are extensions of Kubernetes resources. So they are all in Kubernetes. This is the cool thing. If you know how to use Kubernetes, you will see I can ask kubectl get pipeline from my namespace, and then I will get this pipeline. It's called build and deploy. Okay, cool. This means I can also ask for some tasks, and I will see my tasks there. So you see these are Kubernetes resources, and then they are quite well straightforward to handle if we know how to do these Kubernetes things. So for example, I define my pipeline, and now a pipeline consists of some tasks, and the task can run in parallel or in order. And a task is a collection of task steps. So it's a little bit similar to what a pod and a container is in Kubernetes. And I want to start right away with this first task, build Java app, which now is a little bit specific to Java, but I'm pretty sure you can deal with that, or you can imagine how such a build step would look like. Because what would we do typically? Well, first of all, we need to do some Git, and I can tell you, so this is not even a joke of mine, but I think it's the truth. Having a Git checkout and especially a Git push with proper credentials is probably the hardest to solve problem in CI/CD. I don't know why, but every single technology I've tried out has at least some issues until you get this right. How you store the credentials, how you make sure the keys have the correct permissions, how you have the correct URLs and all of this. So of course you will get all of this code, what I'm showing you, so you can like try it out yourself. And what the things are doing here, we have some steps, and the steps, they inside a task, they run in order, and they run a container. And the container, of course, has an image. So this is really cool, because then we have a nice separation. We have the separations of concerns of what one task is doing. Everything will be contained in an image that is used to build. So if I need something like Java or Maven as a build tool or anything else, it has to be in the image that I use. And also I use a so-called working dir, like a workspace. So the workspace I can use to just save some files there, and inside the same task later do something else with it. So for example, I have first step git checkout, and here you see there are some command line things to just use the correct commands with not getting any SSH errors and things like that. And then I use a Maven command. So this comes with now a Maven image that actually already has some dependencies downloaded. I do this because then the build is faster, because as you can imagine, if I have a fresh installation, maybe you're a Java developer or you have done that, if you build Maven, what happens? Well, it downloads the internet, right? And if you download the internet each and every time, why? Because you're in a container and the container is discarded afterwards. So you have to re-download it each and every time. You can either use what is called a persistent volume inside these tasks to persistently store it, or then you also have to see whether these volumes are fast enough, or if it's actually faster to just store it inside the image. And for dependencies that are often used, I do this. And then I build my application that produces this Java artifact in the workspace folder. And then, of course, we can imagine we have to build our Docker image. Why? Because later on we want to deploy our application. And what I do, I use just a plain Docker file for my Java app. So the Java app will be built with Maven. And then I can use a base image. In this case, I use some Java 14 OpenJ9 installation to just build this. And I build it not using Docker, but using Builder, which is a technology to build container images inside a cluster. And then I build, and of course I push this. And where I push it to is provided by my pipeline run. You will see this later on. So in this case, I can provide some parameters, and you will see this is what I mean with, you have to compile it yourself. You have to compile the cake of your pipeline yourself. Why? Because you have to provide all of these individual parameters. So if you build it up the first time, it can be quite some effort, which is why I wanted to share at least one quite real-world example pipeline with you that you can maybe check out and have a look at. And in this case, our image URL is provided by this parameter, which will be used to push the image. And this is the first task that will run. In our diagram, that is the first task here built. And then we have hopefully a Java app that works and an image. Okay, so what I will do now, I will just make some change to my application and show you how this pipeline works in the real world. Why? Because we want all to see some failing builds, right? So this is live. This is live coding. And of course, if you do live coding, everything can go wrong. You know this probably. So if I now go, this is my production URL, and see the health check, it is already deployed with some version. So that's version 1, version 2. And this is just a default health check that shows me some information. And I can actually now change something in my code and just, well, make sure that it will be rebuilt. So in the health check, this is my, I use a Quarkus application. So Quarkus on Java, maybe you're interested in that. That is a very modern cloud-native framework. And here I have this health check with some data, and I can just update the version from 2 to 3, right? And then what I do, well, now I have this change in this environment, in this repo. So now I just change this here, and what I do, well, of course, I commit and push this change. So always make sure you have proper Git messages so that people know what you did. And then I just push this to my branch. And then what happens automatically, because I actually included some webhooks in GitHub, I can show you this later, that my pipeline already executes. So here I see in this Tekton dashboard, I see that now I have a pipeline run. And I see this on the command line, of course, as well. If I ask for pipeline runs in Kubernetes, Tekton pipelines, then I see that now I have, well, a new run here. And I can, for example, in the dashboard, have a look at the output. And now this is actually running all the individual steps of my tasks. So I have to build Java app task and now git checkout. And this you will see, this is just a git output. Yes, do we have some questions at
Sebastian?
this point?
Yes, we have some question at this point because your application is building and we have a chance to answer to it.
We have a lot of time, so Kirill time to wait until the build, exactly.
So Kirill asks, what about caching dependencies with S3 or anything else? Because if you try to get all dependencies, it could lead to much. You will spend much time for it.
Yes, that's a very good question. So the question refers to the Maven dependencies, and here, if I check, if I look at my Maven output, probably I can try to make it bigger. You see that there's no download. So typically in Maven, you download the whole internet, right? And it takes a long time. And what you could do, like as he says, is absolutely correct. We could have, for example, a volume like in S3 in Amazon Cloud or any other storage in any other cloud, to then persistently store and cache our dependencies. And I will share later on some video course that you can watch where I explain this, how to optimize this specifically for, for Maven. Because the problem or the challenge is that if you try this out, you will actually see that most of the volumes, it depends on the volume type, it's actually not faster. Because you're dealing with a lot of small files, and usually you include the volume as something like an NFS store, and then you can check the performance. But it sounds weird, but it's usually not an improvement of performance, or sometimes it can even be worse just to download it in comparison to download it each and every time. So you really have to see what works for you based on your setup. And what I've seen for these scenarios where you have a standard, where you use some Java standards, that means your dependencies don't change that much. It's actually the fastest way to just include it into your image for your Maven. And then every once in a while, every few months, just update that image with the latest dependencies. And that's actually the fastest way to build it. But you can check out this. I will share the resources later with you, specifically the comparisons that I made there. But Actually, the fastest way is to store it in the image directly. But it's a very good question. It's a very good point.
Okay, thanks.
Do we have some other questions while we're still waiting for a successful build?
Yeah, we have another one from
Please.
Kirill. So he asks, can Tekton so Tekton can do achieve like GitLab? Is it true or false?
Sorry, I didn't understand this. What can it do?
Can it do I don't know, achieve like for Z files, or I do not know what what he
Or like
what he
archive the
means.
builds?
Like archive, yeah.
So I think if I get to archive, like I think the results. So please, he can correct me if I understand the question correctly. So about a build archive to see what is the last, what is the history of the builds in the latest, I don't know, 100 days. So out of the box, it depends how long you keep these pipeline runs and task runs. So first of all, you saw there's a new pipeline run, and this is now with the status of the pipeline, and I can see it, some is the status, if it's green or red and whatever. And now it says succeeded, so green. But you see there are also some old pipeline runs, so from yesterday and then older ones. And then it depends on how long you want to have them around in your cluster. It's very similar to something like a Jenkins installation. It also, like caches your build results for so and so many. And these are Kubernetes resources, so then you could clean them up after a while. But for archive, so it doesn't archive anything per se. What I actually what I would recommend instead is to have some meta information. For example, if you use something like Artifactory or in your Docker Hub, that you say you have your image that you build, and then you provide some more information for that build where it's stored persistently. So usually I would say the CI/CD technology is not the best way to have very long persistent archive, like more than few days. But it's usually very helpful to see, okay, if the build is failing, why is it failing? And then later on, if it's 2 days ago, it doesn't matter anymore. So this is my take on that. If you want some longer archive, then I would recommend to explicitly do an archive step in your pipeline.
Okay, thanks. Let's continue.
All right, so perfect timing now. Just the pipeline succeeded successfully. Great success. So everything worked here. I just wanted to continue with what we're doing here. So now we did the build sources step, and you see this is, if you're a Java developer, this looks very familiar. Build success. So we have a Maven build here. And then afterwards, we build and push our image. This is our Docker image, and this looks very similar to the Docker build output, like step 1, step 2, and so on and so forth. So I'm pretty sure you're familiar with that. Build push as well. So we push the image then to our repository. And then if you remember here, at the next step, we want to deploy something into the not app but config repository, and then run the system tests against the test environment. So what we do, we deploy first to a test environment. We make sure that deployment is successful, so in Kubernetes, and then we want to run the tests. For us, that means in Tekton that we have a new task, which is called deploy system test. The task name is called deploy because I can deploy to any environment. I can parameterize the environment. That's a nice story. And then I can just, you see some parameters here. Which environment? What is the Argo app name? That is, system test. What is the config git URL of my other repository? Which app image, and so on and so forth. So if I check this out, deploy, I see, okay, I have another such task. And then again, I do a git checkout now for the git config environment. I do the checkout, and then what I have to do, well, I have to update all my YAML resources. Why? Well, because I store the desired state in YAML, right? So this is this YAML, like these YAMLs, or actually it will look like, wait a second, like this YAML. This is the deployment of my coffee shop. So this is in the same repository here, and it has something like, well, please use this image. The image has a git hash actually of my application repo. and then, so and so on, and some routing. And this now needs to be updated, this line. And now my pipeline should go and update this. Why? Because, well, I want to update the desired state persistently in my config repo. So here I say, well, just, I can use some command line magic with SCD and whatever, or Q, YQ. There are some tools available. And then, of course, I need to push that as well. So I need to push it into the config directory, which I need to make sure that this Git is correctly set up, like I said before. And then we tell Argo and say, hey, there is a new state in my repo. Just please, apply it. So just, sync and wait for it to roll out. And what it does, I can tell it to wait for it for a successful rollout, so that I just am sure that afterwards my application is deployed. So if I now check out the pods, and sorry, that was the wrong namespace, in the system test namespace, I see, okay, great, this actually has been redeployed a few minutes ago. This was now my pipeline run. And that's the cool thing. I now just deployed my system test application. And then in the next step, I use this to just run the test. And for that, I have a new task, which I have here, run system test, which takes my application repo again. Why? Because there I have some proper system tests that actually test against a proper environment and test my business logic. So that's a really business use case test to create some coffee orders and see whether the statuses are correct, and which resides in a different task to run the system test here. Run system test. At first, I check out my app repository and then I run the test. In my case, I use Maven for there is a different subfolder, coffee shop st for system test. And with Maven verify, I can point them to my application. And the application for the test environment is, I think, test.coffee.daschner.dev, something like this. We'll show you, yes, like this. So you basically take my generic test and say, okay, now point the test against this environment. And then I have a proper use case verification where I just see whether everything works here. And then you probably guessed it, the next step is quite straightforward. For deploying to production, I just update again the config in this deploy step, and then I can also run some smoke tests against the production environment. But once I do the deploy prod task run, which again uses the deploy task, which with different arguments, then I deploy it actually to production, and afterwards I can just verify to see whether everything worked as expected with my production URL, this one. And I can also check out the smoke test in how this looks. It basically looks very similar. I do a git checkout again, and I run then this system tests, which are not system test, the smoke tests, which are in the coffee shop environment as Maven integration test. Okay, great. So this is basically the way how to do this in this Tekton pipeline. And then I can now check out the other tasks here as well. So let's see, deploy system test. I do a git checkout here. So this is the task run there. And then I update the YAML here for my system test image first. So in the system test folder, I commit and push this for the system test image to my git config repository. If I have to push here, then I would need to see it, right? So if I look at this is my other repo, and if I say just pull and rebase the latest changes, then now I actually have these changes that have been done by my Tekton pipeline. So now if I, for example, have a look at the latest change, so this updated actually just the revision and the image from my system test, or in this case, it's a production YAML. Okay, great. So this was that. I wait for the Argo rollout here. So this does the rollout. And then I run the system test against this environment. This is what you've seen. And now there is the Maven output. So actually it just verifies this environment. So if it did this, then I can also test coffee -dev. It could check whether it created orders, and yes, so there are some coffee orders in my test environment which just now have been created by the system test. So my system test environment is really there that I get the confidence in my continuous delivery pipeline. So now I want to see whether this actually, like properly works, which is why I need these different cluster environments, these different namespaces where I can deploy my application to. So in this way, the same thing that would later, or a very similar thing that would run in production, runs here in a system test environment as well, and I can then just use this. Okay, so you see this works, and the test was green. So then we continued for now deploying to production. Very similar, git checkout, update YAML, commit push, and then wait for this rollout. And now if that is the case, my production rollout should be done. So I should see some new pods in the production namespace. And yes, this is the case. They have been deployed before. And then I can also, do some smoke tests to check the health check and things like that. Or now I can create, finally, I can create some coffee. So I can order some coffee. Let's do this. I can check out my production coffee environment. So the health check now says 3. That's a good news. So the deployment worked. I now have the new version, but now this was only for demo. Now I actually want to order some coffee. So I see, okay, there is no coffee order in the system. So I can now order some coffee by just, posting some JSON there. So I typically do something like I order, in my case, an espresso. I will point you to some additional resources where you get this test application from. So if you're a Java developer, this might be interesting for you. So I have a video course on testing, and this is the just example application for my coffee shop there. So I can say, please have some coffee beans from Colombia and produce some espresso type of drink. And now if that is successful, created, then I now should see 2 orders in the system. And here you will see that the status actually changes. So this is what the system does. It has some asynchronous communication between the coffee shop and the barista. And after a while, the status will be updated to collect it. So it will collect the coffee. This is there because I wanted to have an example that's, already a little bit more interesting and more sophisticated than just having, hello world. So we already have some communication that actually the system test verifies. So in my system test example and what is running there, I actually make sure that all of this communication and this ping pong works as expected. Okay, success. Maladies. Now it worked to run my pipeline. And the way why this worked is because I already have some webhook installations for this pipeline run. So I can talk a little bit about that as well. But at first, I would like to know, are there any questions on this matter, what we just saw? So are there any questions, especially regarding the architecture that we have to have the separation between Tekton and Argo, or the specific pipeline steps?
So we have a question about ArgoCD. So the question is how to do rollback with ArgoCD, because as I understand, we deploy via Git commit, and so what we should do to roll back our changes if something goes wrong in production.
Yeah. Yes, because actually this works. We have the possibility to check out the history. So that's the whole point of what we do in Argo. And you can check this out on the dashboard or on the command line to see every sync you do that is a commit in the config git, right? So I just said, okay, this was committed by my Tekton, so now it has a new version. And if I have these new versions, I can actually check out the history and say, okay, now this was deployed, and yesterday a different version was deployed. So I can, check what is the difference there. And in any case, I could just roll back to that version. So then I say, okay, something went wrong, and then I just rolled back to, oh, did I now do it? Oh, I didn't check whether I clicked, but anyway, I can re-roll it again. But then you can say if something was faulty, you have more control over Argo. That's specifically not just say, okay, fail and, undo. You could also say, okay, you know what, there was a bug introduced, like, I don't know, 2 days ago. So please, let's roll back on that state. And with this with this declarative CI/CD, so with the please apply the target state, you are quite easily able to roll back because you just specify the desired history, and then whatever was the case and whatever was stored, you can then undo in your cluster. So yes, that works. In Argo, it tracks the history and what is called revision, and then you can undo it.
Okay, thanks. And I have another question. What about databases migrations? Does ArgoCD have any hooks for it, for rollback hooks like Helm does?
Yes, so not specifically hooks. So first of all, yes, you're right. Database migrations are always a challenge when you do zero downtime deployments, which is the case for Kubernetes. So it's not even an Argo thing. It's more about that we want to deploy something while the user still can use our app. So it's a rolling update and our application stays intact, and then we deploy a new version. And then the problem is not the application, but the database where there's a version mismatch with the schema. So what I typically advise, and I think I produced some videos on that this year, so I can share them with you for Java if somebody's interested, is that you can provide an init container in Kubernetes that makes sure that your version matches what your application needs with a N-1 compatible migration scripts approach. So you say, okay, check the migration scripts and then please apply them to the desired database schema version. So if your application starts, before your application starts in Kubernetes, you say, please run an init container, and the init container goes and checks against this what actually happens and what is included. If you give me 1 second, I can actually try to find this out for you. It should be database migrations, yes, something like this. This actually uses Flyway and Quarkus, which is a Java-based approach, but it works just in general that, I don't have only this video. I think I have, no other guide. It shows you in the video, if you check out my blog here or just Google for my name for this, how to do this in this approach, that you can use init containers in Kubernetes and to apply them before your app starts. So I would say I would not tangled this with the CI/CD technology because it's like in general a question how to deploy your application with zero downtime. If that makes sense.
Okay, that makes sense, and I think we could continue our talk.
Continue for now. Okay, perfect. Yeah, so if you have some more questions, please feel free to ask anytime. Just paste them into the chat, something like that. So what we have now, we have our application that are deployed for a system test and production, and we have a pipeline that now runs. Now I want to show you a few more tips and tricks how to use this Tekton technology, because a lot of things will go wrong when you try to run it yourself, and I can tell you this from my own experience and from projects. So what the first thing is good to know is that everything that we run here is a Kubernetes resource. So if you know how to use your Kubernetes commands, these kube control commands, you will check out and see what actually goes wrong if something goes wrong. So if we check out this namespace, this is regarding for the installation of Tekton, and I will show you later on some resources how to get started, because this Tekton pipelines namespace runs your Tekton pipelines per se. They contain the secrets, like how to connect to your Git and all of these things. And also you will see that actually the pods there run inside this namespace as well. And now you see that all of these tasks that are running actually produce a pod, and a step corresponds to a container within this pod. So what we have here are just all of the pods that were running there that correspond to this, task run that I just had. And then we can check them out what's happening. So if something goes wrong for the task run itself, for the pod itself, we could either check out this dashboard in Tekton. So this is already very helpful to debug something and then see, what is going on. So sometimes here it will show you already. So this is the YAML definition. If we made if you have some problem. Or of course I could say, well, just describe this pod and show me describe pod in this one and show me, yes, of course, in the correct namespace, and show me some events. So these are the Kubernetes events, and if you're familiar with how to look at that in Kubernetes, then you will see, okay, it shows you which images it runs with, and so on and so forth. And if there is a problem with the pod that is with the task, then you will see it here by just debugging this Kubernetes resource. In the same way, you can check out the logs either using, there's a Tekton command line that connects to your Kubernetes as well. So it can, for example, say, well, Tekton, and then give me the task, or just give me some logs here of whatever, of a pipeline run. Or I can have a look at this in the dashboard, that's the equivalent. Or even in kube control, I can check out the logs of a container, right? Because it's the same thing. So if I say, where is my describe? Instead, give me the log files of this container, and then it will tell you, well, which container. So for example, of the, I don't know, build sources step. And then you will see this is the Maven output of whatever you're running there. So this is really helpful. And you can just check this out for example, seeing if something goes wrong in your task run, in your step specifically. And what is also really cool, if you would like to try something out yourself, what I have in this, there's another, let me just quickly open this, Tekton Argo example. I think I did not open this yet. So yes, here it is. It shows you some test task run that I created just for this purpose. And so as a task run, so a run is actually the executing thing. Usually I don't want to create, a run. A run means, just execute a task. I don't want to create this myself because, GitHub, I'll show you this in a second as well, should trigger them. But just as some debugging purpose, I can say, hey, something is wrong in my task and I don't know what. So it just doesn't work, right? That's typically in CI/CD, right? What we typically have, commit history in Git, like fixing CI/CD, fixing CD, fixing CD, still doesn't work. So nie robota yet. What we have to do, we have to debug it better. We have to troubleshoot. What I like to do is to say, please give me access to the container that runs there, and I can try it out myself, because then I can check directories, I can see if something is missing there, and so on and so forth. That from experience gets you to the result much, much faster. And then what it can do is to say, okay, I deploy something that actually uses the same, same parameters. We have a service account with the correct credentials. And as a step, what I can do is just, for example, to say, hey, run here sleep infinity. So what it does, it looks a little bit weird, but I can say, well, just deploy this task run here, and then it will just wait. And I can use a kube control command to execute and just debug this. Let's try this out. So if I have something like testing task run that resides here, if I say kube control apply my Tekton, my testing task run, check out, yes, the namespace is correct. What it does, it creates a task run here, and then it will create a corresponding pod, which is this one. And then the pod is a task, it is a Tekton task, and it runs 2 steps here. And the 2 steps, let's check out the task run here. The first step just checks out my Git, so I can actually see my app repository. And assuming I would now like to test my Maven build, then here this does nothing. It's still running while it's sleeping forever, or for a very long time. And then I can say, okay, now this works actually. And now let me kube control exec to this pod inside this namespace. And I can say this is the container, I think it's called step. Let's see, step build sources. Yeah, step build sources, bin bash. And it says, okay, bin bash is not known, then bin shell, okay. And now I am in the container. And now I am in the container that is actually the running task step. and it already checked out, I'm in this workspace directory, it checked out my Git, and then I can say, okay, Maven clean or Maven package. And if I have some problems here, then it would show me, well, you have some problem there. For example, the Java version is not correct. So I can check, check the Java version and check out everything that I would need or need to probe myself. And this is much, much faster than, updating the YAML, pushing the pipeline, updating the YAML, pushing the pipeline again, it doesn't work, and you spent the whole day and just testing CI/CD. So this approach, I think, is so much faster to have like a task run that is not really there to do some proper work, but just to see if everything works. So I can say, okay, Maven clean work. Now I test my Maven properties here, and if everything there is correct, I can say, please do a package and try to build my application, and then later on I can try to run it or something like that, whether it was built correctly. So all of these things can now be probed with such a task run, which is really, really helpful for just debugging Tekton. And that's probably already the most helpful things for what happens with Tekton and Argo. So these dashboards are really helpful to see what's going on. Of course, if you know Kubernetes, if you know how to use kube control, what a pod is, what a container is, how can I get the information there, what happens if my image is not there, how do I see this error and things like that to get started. In the resources that I will share with you, you will also see how to create, these secrets that I need for providing the credentials for Git in case that doesn't work, and things like that. How we get all of this access. So I really wanted to provide a real-world example for you that you can already use or have a look at if you want to evaluate this technology. So that's basically it. Let's skip my task run here for that as well. Do we have some questions on this topic here for now? While I kill my task run.
No questions, I think, at that moment.
Questions so far, okay.
In our Telegram chat, yeah.
Please. What I did in the meantime, I deleted this task run again. If I check, of course, the correct namespace, then I see, okay, this task is now gone. And now I also want to show you how we can make this connection for GitHub, because that's also a little bit interesting, how to now run this. At first, you can actually do something like, now forget about the task again, now it's the pipeline. How can I run my pipeline like this? How can I actually start it to say, okay, now please go, right? Especially if my Git app is maybe a private repository that's not only on GitHub, because that's very often the case for real-world projects, that it's an internal repository that's hosted somewhere. And how can I make sure that I start my pipeline? And I start the pipeline with creating such a pipeline run. So I can use this YAML like this one, say pipeline run, with not a fixed name, but a generated name. And then I can use kubectl create to create this pipeline run. So this works, but then I have to provide all of these parameters. So typically the parameters are provided in such a run because at least the build revision, which is the Git hash, so the one I check out, if you saw the task, I actually check out always, a specific revision. So not just, latest, because that is not reproducible, but say, okay, which revision do you want to build? Okay. Then my Git URLs, in my case, this is GitHub, but I have an SSH. So if you check out my examples, you can use this for any Git repositories. This is the config URL and the app image that I'm using. So this is created by this pipeline run. I think this should work here as well. If I create this myself, I can just show you for testing purposes. So kubectl create, and that is I think, pipeline run, like this. And there's also, I think, a script for it, yes, to trigger the pipeline run and then show you the logs. So this is one way to do it, but this is more the testing purpose. Why? Because I don't want to, sit there and ping Tekton each and every time when I push something. It should be done automatically, of course. So I can do this, and then it would already start my pipeline run. Hello? No? Maybe? So did it create it? Pipeline run, or did I think so this is another gotcha. I think I have the wrong namespace. Yes, this was of course wrong. What did I do wrong? I forgot to define the proper namespace. So this is the problem with live coding, and this will happen to you as well. So ideally, we recite all Tekton resources in its own namespace. Why? So it doesn't collide with other resources, and especially it doesn't collide with Istio if you have a sidecar injection in your cluster. So this is of course wrong. This cannot work. It does not have all of the tasks. So I can delete this again, delete pipeline run all for this namespace. That was the wrong namespace. I of course want to create it for the namespace Tekton pipelines. And now my dashboard shows me the correct pipeline run. So this is now just a run that I created myself. But this is more like debugging purpose. Why? Because I specified which revision to use. So the revision of the, what will be, where is it here? In the git checkout for the parameter. But of course, this should always be, the one where I did the push with. So what I want to do, I want to have what is called a trigger. So there are some, trigger templates and event listeners that actually make sure that the webhook then starts the pipeline. So how this typically works is that from the outside of my cluster, I have a webhook that will be called from GitHub or from a private own server, where I just say, okay, this is, the webhook. I just have a new event, usually a push, or a pull request or whatever one you want to build. And then for the push, please start the pipeline. How this works, that I create a so-called event listener, and I will show you some resources how to, get started with this for yourself. But just for the idea, what you have, that you have a listener in this case for GitHub, and of course I provide a secret. So something like a secret that you can invent yourself and that you can tell to GitHub, so that not everybody can trigger your pipeline, but only GitHub can. And then also you can, have some for the filters, for example, say, well, the reference, which is the branch, only for this branch. All of the other ones, please ignore. So that is one thing. And then there is what is called a template, a trigger template, which is basically providing a similar information like your pipeline run. And once you have this, then you have the whole connection of how your Git commit in GitHub works to trigger the pipeline in your Tekton. Why? Because you have the Git commit, the Git push with a specific commit version. So you say, well, you just did a push to that branch and this commit version needs to be built. And then in the pipeline run, you say, okay, now the build version will be bound. So there's a binding from this parameter in your event listener request. So this, for example, specifies the revision. The other things could also be specified. For me, that is the case. They are fixed here, and then I can provide some more information, and in this case it will then build it. Okay, so that's pretty cool. And what I then can use, I can actually test this. If you check out the GitHub page, there is a GitHub documentation how it sends its webhooks. So this is quite interesting, I think. So it will send you, your cluster, a request, something like this, that you say, okay, there's an event, for example, push, and it also has a signature, which is this whole payload encrypted with the key that you provided, or signed with, actually, signed with the key that you provided. So then you can be sure that somebody had this GitHub secret that you created in your cluster. And then you can, for example, invoke it with a specific Git hash, and then it will trigger your pipeline. So that's also pretty cool. And as you saw, it already worked. I showed this in the beginning. I did a push to GitHub, and then GitHub triggered this. You can also see the webhooks in your GitHub configuration of your GitHub repo. So you see the webhooks that have been transmitted. And also what you can do in order to debug this, we have a pod in the Tekton pipelines that will be created for these event listeners. What this is something like a server that is just listening to 8080 or some port, I think it's 8080, and then will just tell you in the logs if you have a new call. So it will tell you in this way that you can actually debug it here if it doesn't work. So if we say, okay, this is now the pod that I would like to have the log files here, and then it will tell you, hey, by the way, I would just, for example, I have some event listeners for this pipeline. And the point is here, if something goes wrong, for example, if your binding is wrong, that your template cannot invoke the pipeline run correctly because you made some mistake, then it will show you here in the logs as well. So that's also good to know if you use event listeners that then trigger your pipeline runs. So that's for this repository triggering. And here we have our GitHub repository. So this is my app repository, and I think I can actually check out in the settings the webhooks. Let's see if this works. So we have some webhooks, which I of course created, and there is some webhook here that I then could just have a look at what the recent deliveries were. So here I could check it out. Okay, what is the posting of this payload that I created, and here you see there's a lot of information of the last push that I did. So it will tell you the username and some, I don't know, image even, and things like that. So you can use all of this information to make your pipeline run nicer if you want, right? You can display an image like who broke the build and who was it that triggered the last commit or something like that, and you can further play around with this and make the pipeline quite interesting. So, then the correct person already gets the email that it didn't work or something like that. So you can include this with as many or as much information as you want. That's quite interesting. And we saw already that this webhook works. And this is how you build these things together. Here you can check out the other, that's the config repository. So this is the same contents that I showed you. Where we already had a look at the most interesting resources. There, I also included the Argo configuration. So for example, these applications, that's also a Kubernetes resource. So that's quite cool. If we know, how to deal with these Kubernetes resources, then also the Argo configuration comes as a resource. So you can create Argo just with the same commands by using kubectl, and then it will build up these resources that you saw in the dashboard. And it will automatically, go and tell, hey, this application means go to the production namespace, take everything that's in this repo under the subfolder and apply it, and things like that. The same for the system test, the same for the pipelines. So the Tekton pipelines are also applied by Argo. So the good news is, if we would like to change our pipeline, what we do, well, we just go to this config directory, config repository, and push a new state, push a change, and then we tell Argo that the resources have changed, and it will update also our pipeline. So as I showed you in this diagram, this Argo technology will also just build up the pipeline already with all of these steps involved. So I think that's quite cool. And this is what resides in this repository. In the advanced or further resources that I will share with you, I will also tell you how to build build up all of this. I have a separate another repo where to install it. So for an example installation, there's an example repo to just how to build this up on a Kubernetes environment, and how to install it and how to do all of these things with getting the correct secrets. Why? Because I struggled a lot with this, or a bit with it, and I see this in projects as well, so that it looks straightforward if you have the ideal picture in mind, but then it just fails, as you probably all know. With CI/CD, it always fails in the individual steps, like how to do a checkout of Git, or how to do a push to Git repo, and these are the things that then can become tricky, and that's what we actually want to avoid. So this is why I'm sharing all of this with you, how to install these resources, install Argo, so you can check out that as well. And that comes with this repository. Do we have any other questions for now?
Yep, we have some 2 questions, but I think that the first was answered already. It's about how to use Tekton with multi-branch repositories. So I could you tell about this? I think that it's about we could create several event listener, isn't it?
Yes. So if you have multi-branch, like you would want to have them exclusively, then you have multiple event listeners where all of them say, okay, please equal to this branch, equal to that branch, and so on and so forth. If sometimes, you want to have a more complex scenario, like, first a pull request build, and then, on the same branch, if it's a pull request or not. Yes. So you can have multiple these things, but these filters and events types can be used to filter what you want to listen to. So that's very flexible of, whatever you want to start.
Okay, thanks. And the second question, it's about secrets. So can Tekton use Vault for secrets?
That's a
I
good
suppose
question.
it's a HashiCorp Vault.
Yes, I think so too. I'm pretty sure like this HashiCorp Vault. Um, that's a good question if it can use this out of the box. Let me check this until we get to the Q&A area. I will, after the talk, I will just have a quick Google check. It might be the case here. Why? Because it already comes with some, predefined, things that you can listen to. So in the worst case, you can always build up your own custom, custom logic or something like that. But of course, you would like to have something predefined. I will actually check if that's the case. Yes, that's a good question.
So, and I have another question about secrets. Yeah, so if we not use Vault, so yes, if we use Vault or Vault agent, so we could grab the secrets from Vault, but maybe some small companies do not want to use it, or I don't know, maybe it's complicated for them.
Yeah.
So how ArgoCD could encrypt secrets maybe, so if you should place all your resources as and secrets, environment variables, and so on in the GitHub repository, even if it's private. I think it's to keep secrets in GitHub that are not encrypted.
Yes,
So
that's
how
correct.
do we could fix it?
That's a good question. That's a good question. What I usually advise people is to apply the secrets from the outside. That means not checking them into version control. So I have this, in this example, it's actually a very good example because this is on the public GitHub because I wanted to share it with people, and I don't, want to. I don't want to push my own secrets there. So of course I did not include them. But what I showed in this other repo, how to create them, and you will see if you check out the commands here that they are created on the command line. So this is one example for secrets where you typically don't want to have infrastructure as code, where you not want to have the YAML stored file, or maybe not in the, at least not in version control, but somewhere else, where then you say, before Argo can work and before Tekton can work, I have to apply these secrets manually. So that is one way where I usually say, okay, give it to some system administrator, to some engineering person, and they will then once apply a new secret for that environment, and then everything else works by the declarative approach. So that's one way how to do it. There are few approaches how to do this. We also had it that you say you provide the secrets in the repository, but in an encrypted way, so symmetrically encrypted, and then you provide just the key, so only have one, moving part, you only have one entry point, you provide that manually. So that the first time, for example, you start everything, you create it with a shell script, and then you just provide the master key that can decrypt everything by doing that, and then you still, you can check everything into version control because it's encrypted, and only if you have the key, you can actually check the resources. But then while you're building it up, you have the key like temporarily. So that's also a way to do it. But yes, in general, I would not check them into the version control. So just a few secrets that we have is that are created manually.
Okay,
Answers
thanks.
the question. I can actually.
Yeah,
Mhm.
our time is closing to the end, and I have a question.
Please.
Do you have something in your talk, or we go to the Q&A session, or we are in it?
Something you mean something else here for the talk, for the content?
Yeah. Or we go to the Q&A session and
Yes, just
go to
one
the
conclusion that I
final
would
notes.
go through, and
Oh, okay.
maybe we go through this, and then if there are more questions, please feel free to join us in the Q&A area. That's also always very fun to have some interactive conversations. So as some conclusion, how to use this, and I always like to look at these technologies from a balanced way, because hype doesn't help us much in real world projects. It's nice to give a talk, or nice to play around, but if we build something for real world enterprise projects, we always have to look at the pros and cons. So as of today, Tekton and Argo is already a very flexible solution for anything that is based on cloud native workloads, well, especially Kubernetes. So it basically means Kubernetes with all of the support and all of the documentation and examples that are out there. So as some conclusion for your engineers, you definitely need some Kubernetes knowledge. It helps, of course, a lot if you know how to operate a Kubernetes cluster and how to use these kube control commands. It helps also to have this lower level Kubernetes knowledge. What I mean with lower level is that if you use something like OpenShift, for example, OpenShift has an even better built-in support for Tekton, so you have to do less installation. And there are also some cloud solutions, like IBM Cloud has some way to do pipeline builds where it already comes installed, so it's less effort for you. But I want to show you the Kubernetes way, so that you understand that everything there is a Kubernetes resource and so on. And with that, you can build up a very, very flexible solution. But also, it requires some time upfront to just get started. Once you know how to build up all the individual bits and pieces, and then you saw with my tasks that I have. Once you have the basic tasks, you can use them to modularize everything a little bit more. So there are some gotchas that you will run into. So for example, namespaces. It's recommended to have some separate namespaces, especially to avoid istio collision, how to do a secret configuration. And I will show you some more resources. I will point you to some more resources how to do that, so that you run into less errors. But I think it's an already very interesting combination of technology. And I really hope this talk was interesting. And spasibo большое, and thank you very much for your attention. And if you follow the first link that is here on this slide, you will get all of the resources provided, all of the code presentations, and some video course that you then can watch to see this yourself. So thanks a lot for joining us.
Спасибо, Sebastian. Классный доклад. So
Спасибо.
thank you a great deal. It is very practical and hands-on, so special thanks to you for that. And great thanks to Alex as well for the timely questions. And I suppose you've got at least one person who would very much like to chat with you in the discussion zone. Кирилл, привет. Ты много раз был сегодня в эфире, спасибо. And I guess I'll just ask you to move on there.
Awesome. Yeah, I'm looking forward.
Perfect.